Hey boys and girls, welcome back to Munro Live. Today what's going to happen is Kevin Hardy, one of our crack engineers here, is going to talk to us a little bit about the suspension system, the differences between this suspension system and in some cases the Model Y and in other cases the old Model S. And Kevin, I guess we can start right here with the front cradle.
Yeah, sure.
I'm kind of interested in this because this looks a lot like what we saw in Audi with the node and the extruded parts. And actually, it was also something that BMW did quite a while ago on the i3.
Yeah.
A little bigger than this, but why don't you give us a lowdown on this?
Yeah, it's very common in general, especially with like low volume or luxury vehicles, to kind of adopt this approach. Extrusions are extremely cheap. They're nice straight runs. And it's very, very common. Like I said, like we saw in a lot of Cadillacs, the new CT6 uses a similar strategy here. Now, in contrast to the previous Model S, and it's been a little while, about 7 years since I've seen it and kind of had a chance to go around it, but there was a significantly higher prevalence of extrusions within it. So there was an extrusion that came out here that had like a reinforced rib structure, and I believe there's one also in the rear as well. Now with this, you can see they've gone to the cast node strategy. There's a lot of integration that you gain from here. You can put in tool your pickup points and locating features. You can have some more elegant load paths. You can design in some more failure points or whatever you're trying to do for crash scripts. You can get in significantly more mounting points. So like even with these injector pins here, these all coincide to fastening points with the rest of the system itself. So overall, like I really do like this approach. It's cost effective and enables kind of a lot of accuracy as well.
Well, the thing I like about this is accuracy and consistency. So the guys on the line, when they're popping this thing together, everything's in the right place. Now, with welded extrusions, and even worse, with stamped and welded parts, you're always going to get twisting. You're always going to get things that aren't in the right place anymore, and then you just wind up spending more money on how to adjust it and how to make it so that it's right, shim packs and all kinds of stuff that I really don't advocate. So this is a little more expensive, but ultimately, if you look at total accounting cost, it's a cheaper way to go.
Yeah.
So while we're here, why don't we just talk about the rack?
So as we move towards the rack, one of the things we want to kind of call here, there have been some reports, I believe it was CNBC, about specifically vehicles, Teslas coming out of China, destined for both the Chinese market, the European market, and Australian markets, where there was some chip decontent taking place. Granted, they did not call out the Model S. It was the 3Y, if I remember correctly. We have a NAFTA market or North American market Model S here, so it wasn't in that purview, but we just wanted to show this is our North American Model Y, and this is the North American Model S that we have here currently. It's very possible that given the build date, so this was discussed roughly, I think, Q4, and our vehicle was built in a similar time frame, that future iterations maybe see this, or there's just a very deliberate consideration to avoid the North American market with this decontenting. So we are known to be significantly stricter on some safety considerations.
Well, I think it's more than just safety. I think the other thing is that probably self-driving is something that they want to make sure that they're the first in the marketplace with. And so you look at the markets and which ones are going to be the ones that are like the race to the finish line. And the U.S. market is probably going to be the one that everybody's going to want to hit. So I don't think there's going to be any decontenting in this. I don't know about the Australian market or the Chinese market for that matter. But I do know that in North America, I very much doubt that they're going to give away anything that they don't have to, first off. But I do believe that chip decontenting on something like this for self-driving, I don't think it's going to happen.
So the EPS rack itself is a domestically produced part. It is made in the U.S. The cradle itself does have a call out for made in China. And in the front suspension, you're seeing a mixture of domestic and foreign components. It may have to do with some of the revisions from the previous Model S and the new one. It could also be some Plaid specific considerations. And just cost and what they have already established in China and versus what they're trying to do here in the U.S. and what they're trying to get stood up as far as manufacturing capability.
Right.
The links are relatively traditional. This is a short, long arm virtual ball setup. It is known that in the past, Tesla has had some issues with control arms, with some like catastrophic failure or premature bushing failure as well, and relatively low miles, like sub 100,000. These units look very, very similar, which kind of supports the consideration that it may have just been a bad batch of parts.
Well, wait a minute, weren't they hydraulic as well?
Yes. So in the front here, I kind of stabbed these with a knife earlier, but there's a series of forum posts and videos talking about essentially the bushings failing, but they have gone to more of a conventional setup to probably alleviate that customer pain point going forward, and then may have put emphasis elsewhere in the vehicle to kind of address some NVH concerns. And actually, that's
yeah, the NVH thing. I mean, we've worked on lots and lots of different vehicles from the design up, and hydraulic never really came to it never bubbled up for me ever in any of the cars I ever worked on. I just saw just another thing that could maybe go wrong, especially if I've got air suspension. I mean, I don't know why I would need that if I have this, especially when we get to your magic sensors over here. I think a conventional solid bushing is the right way to go.
Especially with
consistent.
This particular vehicle, the tuning of it and the power. And I think why you saw that some of those failures is, in general, prior to 15 years ago, you never saw vehicles that had this much weight and that much power being put down, prior to this. Yeah. That's kind of like, more in the ultra high performance or race car arena where, you're using solid bushings, Heim joints, things of that nature, where you're making, 1,000 foot-pounds of torque and things of that nature. And typically, I would agree with your consideration for the hydraulic. To me, anytime I've seen it being included into programs, it's to tip the balance sheet, so to speak. Like, we need a little bit more to fully either hit our targets or outperform a competitor, and then they spend the money and commit to hydraulic. Mm-hmm. But as we move, rearward, one of the things that we want to kind of talk about here is this accelerometer. And I know Jordan kind of talked about it a little bit earlier in a previous video, but we did get confirmations from numerous sources about its role and its functionality. So not only does, and its placement being very direct to the source of road inputs, so both from an active suspension perspective, but also active noise cancellation. So it is able to read and pick up inputs from a lot of from their source, from the road, and more specifically, it's able to kind of balance costs across the entire vehicle, where they're able to pull out potentially other microphones or sensors, specifically a third-party, system out of the vehicle. So that's it's.
Well, we're looking here at around $200 worth of savings here.
Yeah, probably. So it's notable.
Yeah, and this is one of the main reasons I'm into vertical integration, because if you have to solve the problem rather than just arbitrarily, I'll just go and buy Fred's whatever, and going and sticking that into your car, guess what? You never really understand or never really tackle the true problem associated with it and find the true meaning of what the right solution should be. So I like vertical integration. I know all the MBAs are turning their TV off right now, but you know what? You're wrong. You're wrong. If you think that vertical integration is bad, you really need to have your head adjusted. Stop talking to whoever that consultant is that told you that, or rip up your MBA, because it's not wrong. It's the way to solve problems. It's the way to get ahead. And if you don't do it, you're going to lose. And quite frankly, we're watching, unfortunately, a lot of folks losing right now. Anyway, let's move on. The air suspension system looks like, I wouldn't say off the shelf, but it looks to me like something that is coming from a supplier.
Yeah, it does look relatively conventional. It is it does have, it's like a at least portions of it are Bilstein unit itself. But to speak to your point, I couldn't agree more with some of the aspects with the vertical integration, especially a car like Tesla 10 or 15 years ago. Sometimes your only option is buying stuff, but you find out very, very quickly that when you start rolling up the cost of buying other people's stuff, it gets very, very expensive, and especially when you're trying to launch a vehicle, I think you end up realizing quickly that you need to cut costs very, very soon and take those problems or issues in-house, even if you can't buy it or build it in-house.
Well, one of the things is you just get additive profit. So you have to make a profit as the OEM, but so do the other guys that are selling you these components. And quite frankly, the hourly labor is still about the same for whether it's inside or outside of the OEM's purview. And on top of that, steel's steel, aluminum's aluminum, everybody has to pay the same amount. The only thing you might be saving, maybe, is a little bit of overhead, but at the end of the day, that guy, whoever came up with this, or that team that came up with this, definitely they earned their salt. They definitely did the job right. So
the rest, I don't want to say the rest of it is relatively conventional, but as far as the the spindle itself, this is another component that is made in China, and then I know it's been brought up before. Sandy, I know it's one of your favorite parts.
It is my favorite part.
I love it. I like extrusions. I'm a big fan of them. But you have some mechanical swaging operations to kind of locate these features. But the big reason you'll see this part, throughout numerous videos, is it is a multifunctional part. And Sandy, if you want to kind of...
Well, the thing that strikes me is that this is a cross car beam. This is one of the things that makes this car handle the way it does and keep you from having any kind of vibrations from a road and whatnot. So that's its first application. This has mounting locations for the HVAC system and the cooling system for the battery. This has got connections for all of the different componentry that runs underneath it and on top of it. And on top of it, the best part, this is the air chamber that you use to basically run your air suspension system. This is amazing, I think, just absolutely brilliant. So when I'm instructing people on how to design product and whatnot, what I usually say is that each part has to perform 3 functions. If it doesn't perform 3 functions, go back and figure out how to do it. And this is doing at least 4 major functions, and then a whole bunch of smaller things that are going on here. And people are saying, well, look at all the machining. This is all laser cut. This goes lickety split. I don't know whose laser system they were using, but we would look at this and probably call on Trump to pop in a whole bunch of holes like this, and it'd be done in no time flat, faster than you can basically see. Done. These things, this is to me a work of art. This is a real engineer. A lot of the other stuff that we see, I mean, almost anybody can do it, but this is a team, actually. It's not going to be a single engineer. It might be one engineer leading the way with an idea, but everybody has to contribute to this to make sure that each and every different aspect of this product or the results of this product is fully integrated into all the other, like the HVAC system, like the heating and cooling system for the battery, on and on and on. Everything has to be focused on here. How do we get the maximum amount of usability or functionality, whatever term you want to use, out of this cross car beam? So I'm really impressed. I love this thing. I'll put it in every video if I can. Let's go to the rear.
Alrighty. So as we work our way to the rear, a lot of these components they may be, but specifically the Cradle is kind of Plaid bespoke. So almost every link here these castings themselves are coming from China. So you have that kind of interesting mix of the domestic and foreign sourcing of it. I understand why. It kind of bums me out. I try to buy domestic as much as possible, but I do understand they may have a capability or tool availability or press availability there, and it is a little cheaper, and they don't build a lot of these units. I think it's like roughly 20 to 25,000 for the Model S, and then the Plaid is a smaller subset of that, so it does make sense.
Well, one of the reasons for that is because We've kind of, in the United States, we've kind of blocked our path for utilizing materials from other countries, and unfortunately that hurts our price because there's a tariff on them. We don't make aluminum here. Well, we do, but it's in such small supplies. It's like ridiculous from a business standpoint. Whereas China, they're making the aluminum. They're making the dies. They're shooting the product. Again, vertical integration.
Yep.
Oh, did I say that again?
Yeah.
I can't believe it. I'm sounding old, like I'm repeating myself.
But yeah, so the Cradle obviously is a large two-piece casting. What's awesome about this is from a cross-car slip perspective, you know, the front Cradle, it does have multiple pieces. You have the extrusions being brought and welded in. The reduction in kind of tolerance stack-up concerns with this is reduced. And you can kind of tell with that also about this upper brace piece. So this is nested in place, and you can look here and see just how concentric the witness marks are from the mounting points here. So you'll see the threaded hole comes up, the fastener hole, and then a little weep passage for water build up. But as you can see here, I'm putting some side kind of load on this, and it's fixed in place. So you come up here, and there's essentially like a near net interface, you know, with this particular piece. So there is machining going on. There are, you know, it would be in a jig, fixtured and located. But as you can see, this part goes on pretty well, you know, from the first time perspective.
So anyway, while you've got that off, let's just discuss this. Now,
Yeah.
this has got holes going in every different direction, and people that don't know what they're talking about would say, oh, well, this is not a very good design. Everything's supposed to come in one direction. Yeah. So this is done on a machine that's going to basically pop all these holes, and the head is going to turn. It's a 6-axis machine, maybe even more, and it's going to be doing, if it's got a trunnion, it's going to be doing all of this, and it's going to probably be doing it in one machine. You don't have, for the low volumes like this, there's no point in having any kind of a machining line. It can be done right there. Now, when I first saw this, I got, oh no, that's like, as a tool maker, this is not what I want to do. But if I'm using a CNC machine, I've got a single cutter that's going to be able to face the top and then just burr around here, and it'll be dead accurate. And that gives us accuracy, which actually makes the line side operation so much easier. And again, like I talked about on the rear Cradle, there's no shim packs, and there's no adjusting here and there. This thing's dead accurate. I don't need to do anything, and I don't have to try and straighten it. It's done. When it comes out of the mold, boom, done. And I don't have to worry about any kind of warpage like for welding or, and then the other thing is, if you've got somebody who really understands aluminum and they've done the molds, vertical integration again, they're not going to have a problem with the aluminum warping, because aluminum can warp, because they're going to control the aluminum that's purchased. There's always some eager beaver purchasing agent that wants to get a good price on steel, and as soon as the steel comes from a new source, guess what? All the guys on the stamping line are going crazy, because the steel isn't acting exactly the same as what the other stuff did. Everybody's got their own secret methods for making these things happen, and when the raw steel starts showing up, it could warp. It could have a little less alloy in it, could have a little more alloy in it. So you get spring back and all kinds of other crap. This is the way to go if you want to have a first time right kind of product. So I'm really happy. I love this. I was shot down pretty much every time when I started talking about going to aluminum as opposed to stamped steel. Whatever. Those guys are probably all retired and dead or something like that. I don't know.
If you do want to come around, you can kind of see the machining operations here where it is near net. And it's a little ovaled here. They do have the capability of slipping, but as we showed you, on the left-hand side, extremely concentric, lineup of fasteners. So
yeah, the fasteners, they're doing the actual primary location. Once you bolt those down, this should be sitting in the center, and we can live with a millimeter or whatever it is that's it's not even a millimeter of slop, half a millimeter of slop. Yeah, good deal.
Yeah, no, it's a great execution, especially for the volume. It's always something that we're balancing here with some of our customers is their production volume, what they're
Yeah.
trying to do, what they're trying to achieve. We're
Yeah.
balancing kind of excessive weld considerations with the customer now as we kind of go through some stuff. But when you kind of get to the links here themselves, and to be fair, I'm not a chassis guy, but nice long straight links. On the old Model S, one thing that was kind of interesting is the camber link itself, which is shown here, was actually a nice straight extrusion. Again, I kind of told you I love extrusions. They're simple, they're cheap, but it was very straight. This here has a jog. This is not uncommon to have a notable jog in this for clearance with your motor bay or your aft engine bay rail. Or why do I keep saying engine? Your aft body rails.
Yeah,
so, so that's not uncommon. But on the previous one, they were straight and very straight. And I know a lot of customers kind of complain about like excessive tire wear and things of that nature. It kind of comes with the territory. Again, this is a heavy vehicle, much like SUVs that have excessive, front tire wear. It is kind of part of it. But it is interesting that on the next kind of iteration, we see they go to I want to say more conventional in the sense of profile. So this kind of U shape that they do have is very, very common on a lot of multi-link rear suspension vehicles because they need it for clearance and they want to control the camber gain as much as possible as they kind of move through.
Yeah. Again, these ones are all Chinese as well.
They are all.
Yeah.
Yep. They're forged. They are strong. There are sizable sections, around all of this to kind of hopefully alleviate any issues they would have with performance. But as we kind of, I guess to that point.
Well, one of the things that we can bring up is, I'll bet you dollars to donuts, this supplier and that supplier is the same supplier. Because again, Tesla has always had a problem with suppliers. They don't want to work with them because they don't have huge volumes and they don't want to get involved with, Tesla. That's a really small company. I want that big, big GM order or something like that. At the end of the day, these guys in China, if it's aluminum, they'll figure out what they need to do. They do thick molding, they'll do the forgings, they'll do the, in some cases, cast arms. They'll do these castings here, bigger castings. And the reason for that is because they think differently than we do. They don't think like, I'm going to be just a casting guy or I'm going to be just a forging guy. They think, I'm working in aluminum. I want to do anything that aluminum can do or can be shaped or whatever. They're going to do their own machining. They're going to do their own forging. They're going to do their own casting. They're going to do anything, including bending and whatnot, and extruding. I've walked through dozens of factories that are making product, and the factories are huge, and they run the gambit. They do everything, and in some cases, that company will be attached to the parent company, and the parent company manufactures aluminum.
Yeah.
So they alloy it out. So looks like same.
Yeah,
sort of
similar. Yep, for the rear as well. It'll be interesting to see as some more capability in the United States stands up in Texas and other places, whether or not we see these parts come back domestically or if they stay, overseas. It might make sense to kind of keep some of those more unique or bespoke parts there.
Well, it's going to be difficult because of the embargoes and tariffs and taxes and whatnot. We don't manufacture that much aluminum in the United States, and quite frankly, it becomes expensive. And then by putting taxes and tariffs on bringing in aluminum from other countries, it just basically kills the manufacturing capabilities that we could have here, but don't, because we can't get a hold of the raw materials. So anyway, the other thing I wanted you to talk about a little bit is the tires.
Sure. So kind of to the point of the camber arms, and I'll kind of bring this around. So this is the tire that comes from the factory, from Tesla, a Pirelli P0 performance tire. The Tesla store distributor.
Tesla store,
they place the
Tesla place.
Yeah, the all season or winter tires on this for us, given that it's Michigan and it's cold now, and that's not exactly the tire you want to be rolling around. But to the point about the kind of camber gain consideration, where you can just tell as you might want to zoom in a little bit. So there's round, a little bit of these leading edges of the lugs are rounded off relatively aggressively because Corey put it through its paces. But when you look through on the inner portion here, you can see just how much more aggressive the wear is on this vehicle. And again, it's not something inherently like a design flaw. It is kind of the nature of a heavy vehicle being driven hard, and it's kind of a byproduct of some of the inherent like architectural characteristics. But one of the things that to kind of tie back to the overall like noise, drivability considerations is you can kind of hear the tire here, and then this is an OEM equipped with foam insert, and there's a considerable difference in noise. And performance tires in general are not known for being quiet. So we just wanted to kind of bring that out to show you guys with respect to kind of the camber wear issue, the quietness, and some of the effort that Tesla is putting throughout the vehicle to get them quiet. If I remember correctly, ours was a little noisy in some areas when we drove it. But
the noise, the biggest amount of noises that we had was because of the one window.
Yeah.
And that had nothing to do with tire slap or anything else like that. I thought the car performed remarkably well. So for me, the only thing I've mentioned, I didn't care for the back seat.
Yep.
And about that, that's about it. Everything else to me worked wonderfully well. It's a really good car. There's one thing though that we didn't touch on, and that is that you'd think with all the extra power, somehow there'd be a different braking system, but that is not what we found.
Yeah, from what I understand, and we didn't do a complete deep dive, go through all the part numbers or anything like that, but there is some complaints with regards to braking performance. It does appear that it is essentially common with the regular Model S. Again, this whole balance of performance, there's already a lot of weight in the braking system, in the vehicle itself, but it doesn't appear to be any unique considerations. There may be a pad material change for this, but overall, it seems to be common with the regular Model S.
Anything else?
Is there anything else you wanted to? No, I think
we touched
kind of
on
good,
pretty much everything. Yeah.
Overview itself. Corey would like me to at least bring up, if you do like this sweet vest that Sandy has on right now.
Oh, really?
Yeah. By request, kind of like a special order thing. They are doing them. They are available if you like it. They're pretty nice. It is Patagonia. So I don't know if it's going to go up on the website or whatnot, but that is available. And we're also selling some of the, I believe, stator plates, laminates.
Laminates.
So both signed and unsigned.
Yeah. And
they're going pretty quick.
Yeah. These are going a lot faster than we anticipated, and we don't have that many. So if you'd like to have something like this, this is earth-shattering. These are not like anybody else's laminates. Nobody has anything that's even close to this. This is. These are breakthrough technologies that Tesla's come up with. So, like I said, we don't have very many of them left. I would highly recommend, if you want to have something that was the first into the marketplace, this is kind of a cool little thing to put on your desk. Now, we've been asked whether we can make any of these things fancy. I'm not sure whether this is coming up on Easter or whatever, but one of the things that we've been asked is, can we gold plate them and sell them? I have no clue how much they're going to go for, but if we do it, there'll only be 100. We will only do 100 of these things, and they'll be gold plated. If you're interested, I'm not going to gold plate a whole bunch of them and then find out nobody wants them. So if you're interested, let us know in the comments, and we'll see what'll happen. So anyway, with that, I'd like to thank you again for watching Munro Live. Thank you, Kevin, for
no problem.
all your instruction and wisdom here. And stay tuned. There's more to come on the Tesla Model S Plaid. Thank you all for watching. Bye now.